In a previous video, we discussed adding intersections to a management group and vehicle phases to intersections. In this video, I'll dive a little deeper into intersection and processor settings, such as adding pedestrian phases to an intersection. So let's start by going into the Edit Intersection screens. To do that, I will open up the Metcalf Avenue Management Group that I created within the In-Traffic Configuration tool in a previous video. Again, you will see a map displaying the location of every intersection within the management group. I want to further define settings at an intersection, so to do that, I will click the intersection on the map, and then I'm going to click this little icon at the top of the map right here. Alright, so this is the Edit Intersection page, and there are 4 tabs on this page. The General tab displays the latitude and longitude coordinates of the intersection. You can move the intersection by clicking and dragging the icon on the map. Once you drag the intersection to a new location, the latitude and longitude coordinates change to reflect that movement. The Device tab right here shows the device that is assigned to the intersection, along with its IP address and serial number. You can assign a different processor to the intersection by selecting a new processor from the Name drop-down list box. You can also assign different rhythm devices to the same intersection by selecting the Device Type button up here, and then selecting the device name from the drop-down list box. Just remember, before you can assign a device to the intersection, the device must be added into the In-Traffic data repository using the Device Management tool. For InSync processors, there are 2 special settings that can be set on this page. InSync's heartbeat is a micropulse sent to the detector card every minute. Turning heartbeat mode on prevents detector diagnostics in the controller from falsely faulting a detector. This setting can either be turned on, off, or off in detector mode. I recommend that you enable heartbeat mode if detector diagnostic mode is turned on in the controller. At all other times, you can leave the set to off. Recovery mode over here is InSync's method of recovering from an interruption to its adaptive service caused by a preemption. Now, historically, preemption causes issues in a coordinated traffic system because the preemption call causes coordination to get out of step. It can take several cycles before signals can get back into coordination after a preemption. Preemptions to coordinated service are usually caused by emergency vehicles, railroads, or a watchdog service interruption. You probably know what emergency vehicle and railroad preemptions are, but let's take a minute to discuss the concept of a watchdog interruption. The watchdog is InSync's method of servicing any phases that have been waiting for a long time. This could be caused by controller preemption, unintercepted pedestrian calls, unintended configuration problems, or incorrect controller settings. In any situation where a phase has waited an excessive amount of time to be serviced, the InSync's watchdog kicks in and services these phases. After the sequence is finished, or if the phases that have been waiting a long time have been effectively serviced, InSync will then enter recovery mode. So getting back to recovery mode, this option allows you to define how you want the system to recover from these interruptions. You can disable recovery mode by selecting the Disable Recovery Mode checkbox, or you can leave it enabled and define the maximum and minimum amount of time in which recovery should take place. To give you an example of when you would want to use this, say that you have a railroad located at this intersection, and you have a preemption in service caused whenever a train passes. If you want the controller to do an exit sequence, say for like 40 seconds, you can then set the minimum recovery time field here to 40 seconds to accommodate for that exit sequence. So in the fields below, you would type the minimum number of seconds that should elapse before resuming normal optimized operation in this minimum recovery time field. In this case, I would type 40. In the maximum recovery time field, you can enter a maximum number of seconds that should elapse before resuming normal optimized operation. I'll go ahead and enter 55 seconds in this field. The Movement tab up here is for defining the vehicle phases at an intersection. To add a phase, click the plus icon, select the movement direction, and then select the phase number to associate with the movement direction. You then click Add Movement Phase. Removing phases is just as quick. Just select the phase number and movement arrow at the top, and then click the Remove button. The Pedestrian tab defines the location of pedestrian phases and which vehicle phases run concurrently. You can also set up pedestrian phases to run exclusive of vehicle phases. The pedestrian settings applied within this page will always apply to the intersection, no matter what configuration it is a part of. You can, however, override a pedestrian setting to let it run automatically when an associated vehicle phase runs. This is done as part of setting up a configuration, and I'll go over that in a later video. So let's dive deeper into this page. Looking at this, I have not defined any pedestrian phases for any of the intersections. So when you first open this page, it's going to look like this. To add a pedestrian phase, I'll click the plus icon, or I can select Add Pedestrian Phase from the menu up here. So let's do that. The page changes so that you can add pedestrian phases. I'll go ahead and add a pedestrian phase for this intersection by clicking the PED phase number here. In this instance, I'm going to add PED phase 2. Now, pedestrian phase number should correspond with the vehicle phase that is concurrently running adjacent to it. I'll then type in the amount of seconds that the walk sign should display in the walk timing field. In this case, I'm going to have 7 seconds. I'll then go to the clearance timing field and enter the amount of time that the flashing Don't Walk sign should appear. In this case, I'm going to do 12 seconds. The field over here is for running a pedestrian phase automatically with the vehicle phase, even when there's no demand. This is called running non-actuated, since a button has not been pressed in order for the phase to run. If you want the pedestrian phase to run automatically when the concurrent vehicle phases are green, you will click this non-actuated checkbox. By enabling this checkbox, the interval length field displays under it. This is the number of seconds between running the pedestrian phase while the concurrent vehicle phase is green. So this option really allows for recycling of a PED phase. So say you have a concurrent vehicle phase that is running for 55 seconds, and the pedestrian phase is set to run with it for a total time of 17 seconds. You've set the interval time here for 20 seconds. This means that the pedestrian phase will run 17 seconds, be off for 20 seconds, but since there is still time left in the vehicle phase, it'll recycle and run again for another 17 seconds while that vehicle phase is green. This Prevent PED Recycle checkbox right here is for preventing the recycling of a pedestrian phase even when there is demand on the pedestrian phase, the hold input is active, or the pedestrian recycle input on the controller is active. You would want to enable this option if you have a PED button that is stuck on and continuously sending a PED detection call. It can also be used with flashing yellow arrow suppression packages, which prevent pedestrian walk signals and flashing yellow arrows to be on at the same time. In this case, we would want to enable the Prevent PED Recycle so that the pedestrian walk signal does not recycle and turn on when the flashing yellow arrow is operating. If the pedestrian phase runs exclusive of a vehicle phase, you can select the Exclusive Pedestrian Radio button. An exclusive pedestrian phase dedicates an additional phase for serving only pedestrian traffic. When specifying that the PED phase is exclusive, no vehicle movements are observed. Exclusive pedestrian phases reduce the potential of accidents occurring between right-turning vehicles and pedestrians, but it does come with a cost, as it does increase cycle lengths and delay for vehicle traffic. Now, if the pedestrian phase runs concurrently with a vehicle phase, you'll want to select the compatible vehicle phase radio button right here. You'll then select the vehicle phases that run at the same time as the pedestrian phase. You may have also noticed this dummy button right here. The dummy button is for management groups that have been imported from InSync 1.4. This was the method used to create an exclusive pedestrian phase prior to InSync 1.6. For InSync 1.6 and above, a dummy vehicle phase is no longer necessary, as it is handled with the exclusive PED phase option. Finally, to add the pedestrian phase, I will click the Add button, and the phase is added to the intersection. So let's go ahead and add 3 other standard phases to this intersection. I'll add phase 6, change the walk timing to 7 seconds, clearance timing to 12 seconds, and I'll have PED phase 6 run at the same time as vehicle phase 2 and 6. For PED phase 4 and 8, I'll change the walk time to 10 seconds and the clearance time to 17 seconds. I also want this phase to run automatically when the vehicle phase runs, so I'm going to select non-actuated. And I'll leave the interval length alone. And then I'll go ahead and select phases 4 and 8 to run concurrently with this phase. And then I'll click Add. I'll go ahead and do the same thing with vehicle phase 8. Okay, now we see a list of PED phases that have been added. Now, if you want to remove a pedestrian phase, all you have to do is select a radio button to the left of the pedestrian phase that you want to remove, and then click the Remove button. Now, if you want to change any pedestrian phase settings, all you have to do is select the radio button to the left of the phase that you want to change, and then click Update. The fields for editing the phase display. So I'm going to go ahead and change this one, the interval field, to 35 seconds. And then I'll click Update. Additionally, you can change the intersection name from any of these pages by clicking on the name up here. As you can see, I can now type in the field. In this case, I want the intersection name to reflect the cross streets, so I'll go ahead and type the cross streets into the field. I'll then click Save once I am done. So that covers all the device and intersection-specific settings that you can set for an InSync processor. Once you have done this for each intersection, you are then ready to start defining configurations, which I will cover in the next video.